Okay, so we briefly want to look at the concept of integration. Okay, and once again, we'll introduce ourselves to the very basic rule and do some computations, okay, with the basic rules in preparation for our examination. So this is the basic rule. If we are given a function, okay, kx raised to the power n dx, and we have to integrate, okay, the notation is what we are seeing. So integrate, this is the function, okay, and we are integrating with respect to what? To x. Okay, good. Now let me just take a very basic example for you to understand this. So for example, if I have 2x raised to the power 2, now I'm asked to integrate with respect to x. Okay, good. How do you go about that? The rule says that first add 1 to the exponent here. Okay, so it will still be 2x raised to the power 2 plus 1. Okay, then divide through by the resulting exponent up here, which will be 2 plus 1, which is equals to what? 3. Then add what we call as the constant of integration. Okay, so your final answer will be 2x cubed over 3 plus c. Good. So if you notice, it's exactly the direct opposite of or reverse of what? The differentiation. Okay, good. Now let's take another example. So integral of, let's say, 5x cubed dx will be 5x raised to the power to add 1 to the power. So that will be 4. Then we divide through by the resulting power, 4. Okay, then we add the constant of integration. So this is our final answer. Good. Now, the very last example I'll demonstrate is the case of a function like this, x raised to the power -1 dx. The rule says we should add 1 to the exponent, right? But in this case, when we try adding 1, when we add 1 here, -1 plus 1 will give you 0. And then if we attempt dividing by 0, we'll get what? Infinity. So which means that for this particular function, okay, which is 1 over x, so for this particular function, which is integral of 1 over x, okay, there is a unique solution, which is what? Ln of x plus c. So the integral of 1 over x is going to give us what? Ln of x plus a c. Okay, so let me also touch on something before I give you some examples to try. Assuming, sorry, assuming, yes, for the same question, let me just use the same questions we have on the board. Okay. We can also simply factorize because these numbers here are constants. Okay, we can also, before we integrate, we can bring the constant out and then integrate the x cubed with respect to the x. Okay, so this will be 5 times x raised to the power 4. You add 1 to the power and divide by the what? The resulting power. Okay, then introduce your constant of what? Integration. So you get the same answer, right? Good. Now let's try some examples. Let's say integral of -7 x raised to the power let's say 6 dx. Okay, then let me give you another one. Integral of 5x raised to the power, let's say -3, the -3 plus, let me add another function, so 4x raised to the power 2. Okay, then everything into bracket dx. Let me give you a clue on the second one. It's the same as what? Integral of 5x raised to the power -3 dx plus what? Integral of 4x squared dx. So find the integration for me. Integrate both of them for me. I've given you a minute to do it. Okay. So I want to believe you are done with your solutions. For the first one, I expect you to get -7x raised to the power 7, okay, all over 7 plus c. So that can further be simplified as what? -x raised to the power 7, okay, plus c. Then let's see the next one. So this will give us what? Like I said, you can bring the constant out. Add 1 here. When we add 1 here, it will be -2. S raised to the power -2 divided by what? -2. Okay. Plus 4x raised to the power 3 divided by 3. Okay, then introduce the constant of integration, which was c. So this becomes -5 s raised to the power -2 over 2 plus 4x cubed over 3 plus c. Okay. So that turns out as our final result. Okay. If there is any question, you can ask. If there's any question in class, you can ask. Yeah, Joseph Edu.
So the last one, why -5?
There's a negative in the denominator.
Okay.
So it will come up.
So the negative down there will move to the top.
Yes.
Okay. Thank you, sir.
You're welcome. Okay. Yeah, so let's move on. Okay. So like I was saying, the first two we've already looked at. The next 4 we want to take note of it. The integral of e raised to the power x dx is e raised to the power x plus c. Integral of sine x dx is negative cos x plus c, and then integral of cos x with respect to dx is going to be sine x plus c, and then integral of sec squared, okay, with respect to x is equal to tan x plus c. Now, as an extension for integral of e raised to the power x, okay, if you also have e raised to the power, there's a coefficient a. So integral of e raised to the power ax dx, okay? Please take note of that too. That will come out as e raised to the power ax, okay, divided by a, okay, plus c. So take note of that as well. Okay, good. Now, yes, I think for now, let's look at this and then try some examples on them. Okay, so don't forget integral of sine is negative cos, integral of cos is sine, integral of sec squared x is equal to tan. Okay, so let's try some examples on what we have just looked at. Okay. So we have a nice question like what you have here. Okay, we have to integrate 4 sine x plus 7 es dx. Okay, so in our solution, this is just going to be the integral of 4 sine x, okay, dx plus what? Integral of what? Uh, Integral of 7e raised to the power x dx. Okay, good. So this will give us, if we are integrating, you can bring the 4 out, like before we said, sine of x, okay, dx. Then once again, you can also bring the 7 out to see it clearly. Integral of ex dx. Okay, good. So when we integrate sine, what did we say we get? We're going to get negative cos. Okay. When we integrate sine, we get negative cos x. Then plus 7. When we integrate e raised to the power x, you still get e raised to the power x. Okay, plus what? Plus c. So introduce the constant of what? Integration. So the final answer will be minus 4 cos x plus 7, okay, e raised to the power x, then plus c will be our final answer. Okay. Yeah. So probably let's just try one more example. Let's set a question. So let's say we have 1/4. Okay. Then we have cos, okay, x minus maybe 5 e raised to the power 5x. Okay. Then we're integrating everything with respect to x. Okay. This will be the same as 1/4 cos x dx. Then we have minus 5, okay, integral of e raised to the power 5x dx. So when we integrate, we get 1/4, okay, cos x will give us sine of x, then 5 times e raised to the power 5x will give us e raised to the power 5x, okay, over 5. Okay, then introduce the constant of integration. So this 5 will cancel out this 5, and our final result will be 1 over 4 sine of x minus e raised to the power 5x, okay, plus c, which will be our final solution. Okay. So having solved this, let me also introduce you to the concept of definite integrals. Okay, so far everything that we solved, we just had an open integral, okay, for the integration. What if I ask you to integrate from, let's say, 0, okay, to say 3, okay, of the function maybe x cubed with respect to dx? Yeah. So here the key difference is you integrate all right, just like we know, which will be 3x raised to the power 4 over 4. Okay. But in this case, because you'll be putting in the limits, the lower limit and the upper limit into the function, you don't have to bring the constant of integration. Okay. So how do we also put the limit in? The bigger value or the upper value will be substituted where you see x. Okay. So that will be 3 raised to the power 4. Okay. Divided by what? 4. Then minus. Then you substitute the smaller value also where you see x. 0 raised to the power 4. Okay. All divided by what? 4. Okay, so this will give us 3 raised to the power 4, which is 81 over 4, which will be our final answer. Okay, so that will be 20.25. Okay, as the final answer. Okay. Now let's try one more example. So assuming I ask you to integrate integral of 4. So integral of 4 sine, okay, x from 0 to pi, okay, with respect to dx. So this is going to give us 4. When we integrate sine, we'll get what? Cos, negative cos. So you get minus cos of what? X. Okay, good. But take note, we are going to what? Substitute the limit of integration. So from 0 to pi. Okay, good. So this will look like this: 4 times negative. In fact, the negative 1 can even come out. So negative. Then we have cos of pi. Cos of pi plus, sorry, minus cos 0. Okay, good. So let's see what we're going to get when we find cos pi. Here is 180 degrees. Okay, so pi is 180 degrees. So cos of pi, we always know that the cos function is between 1 and -1. Okay, good. And at cos 0, we are at maximum. At 90, we are at 0. Okay, and it keeps going forth and on. Okay, so at cos 0, we are at positive 1. At 90, which is pi over 2, we are at 0. And then at cos 180, which is pi, we are at negative 1. Okay, so that your calculator should be able to give you. So cos 180 is negative 1 minus cos 0 is positive 1. Okay, times minus 4. So negative 1 minus 1 will be minus 2. Okay, so which means that we'll get an answer of minus 4 times minus what? Minus 2, which is equals to positive 8. That's our final answer. Okay. If there are any questions, you can ask. If there's any question, you can ask. Yeah. Joseph Edu.
So please, the down there, I cannot see it well.
Okay.
The last point, step that we did right now,
Yeah.
I can't see it.
Well noted. I've heard you. What is your question? Yusuf Habib. Yes, Yusuf.
Yes, sir.
Yes.
Please, I wanted to ask about the cos pi.
Yeah.
You know that pi is 3.142. Can you put it in place? Can you substitute it as cos 3.142?
No. Here you see 3.142. Okay, is not in angles. Here we are talking about cos one. Cos is a degree function. So if you are putting it here, then you have to change the pi into degrees. So
Okay.
that would be 180. But if you want to use a 20/7, then you have to convert into radians, which will be confusing.
Okay.
Do you understand?
Yes, sir.
So,
Thank you very much.
welcome. Yeah, I think on to this is a very short details I want you to know about integration, how to integrate both indefinite and definite integrals. Okay, good. And I will end off with you at this point. Okay, now